In this example problem, we are asked to determine the center of mass of the assembly below. Alright, we're given that the cone that the cone in this situation has a density of 8 megagrams per meter cubed, while the hemisphere has a density of 4 megagrams per meter cubed. Alright, and we're given that for the that there's also a 25 millimeter hole, cylinder hole in the center of the cone here. Right. So what we're going to do here is we're going to break this. The first thing we're going to do in order to solve our center of mass equation is we're going to break this part assembly into different parts. All right. So Alright, so we can say this whole shape here, we can say is equal to the sum of our hemisphere plus the sum of a cone, alright, plus minus the tip of that cone minus the cylindrical hole in the center. So once we have breaking our assembly into parts, what we're going to need to do is we need to determine, so what we're looking for here is we're looking for x bar, y bar, and z bar. Alright, so since we have x, that all four of our shapes here, their individual x bar and y bars are both at, or like the x tildes and y tildes are all at 0, we can say that x tilde and y, or x bar and y bar would be equal to 0. Alright, due to that symmetry about the z-axis. So the only thing we need to solve for is z bar. We know we can solve for z bar would be equal to the sum of all the masses of our components. I should say that z bar is equal to the sum of all the centroids of our individual components times the mass of each of our individual components divided by the mass of each component. Alright, so we have 4 parts, so we're going to say we have part number will be, so our last step here is we're going to calculate z tilde and m for each, and then we're going to take this, after we do that, we're going to sum up z tilde m and our total mass of our system in order to determine our body here. Okay, so for the first part, alright, which is our hemisphere, alright, or z tilde for our hemisphere, we're going to go back to our table. So for a hemisphere, we're given that z tilde is equal to this distance here, which is equal to 3/8 over r. Alright, so if we go back, alright, it would be equal to 3/8 times 50 millimeters. So that's equal to and then it's going along the negative direction. It's along the negative z-axis here, so it'd be equal to minus 18.75 millimeters. Alright, the mass of our part, or of our body, for number 1 is equal to rho times v. Alright, so in this case, rho of our hemisphere was equal to 4 megagrams per meter cubed. And then we have our volume. And then our volume for a hemisphere would be equal to 2/3 pi times the radius cubed. So in our case, the radius was equal to 50 millimeters cubed. If we multiply, let's see here. If we multiply this by 1 kilogram, so for 1 megagram, that's the same thing as 1,000 kilograms, and then 1 meter is the same thing as 1,000 millimeters. And if we cube that, if we do that, what we end up getting for our total mass in kilograms, it would be equal to 1.047 kilograms. Alright, and then so we can then repeat this process for parts 2, 3, and 4. So for part 2, which is our cone, z bar is equal to h over 4 for a cone. The total height of our cone, we saw that at the base of our cone, the diameter was 50 millimeters, 100 millimeters up in z, the diameter was reduced by half, so it was at 25 millimeters, and then another 50 millimeters up, we would reach the top of our cone. So the total height of our cone is going to be about 200 millimeters. So I'm going to say 200 millimeters divided by 4 will give us 50 millimeters. Alright. The h over 4 value I got from the table a few pages back. And then for the mass of a hemisphere, we need to know the volume of the hemisphere, or for the mass of our cone, we need to know the volume of the cone. So the volume of a cone is equal to 1/3 pi times the radius at the base, which in this case is 50 millimeters, squared, times the height of our cone, which in this case is equal to 200 millimeters. Alright, and then that gets multiplied by the density of our of the cone. So it would be the same process as we shown up above. So it would be equal to 8 times 10 to the minus 6 kilograms per millimeter cubed. If we multiply that all out, we would end up getting 4.189 kilograms. Alright, and then for part 3, we have our cone here. Our cone in this case has a height of 100 millimeters, but it is at a it is already at the base of our cone is at 100 millimeters tall. So to get our z tilde, we have to add the 100 millimeters plus h over 4, which in this case our height is 100, so it would be 125 millimeters would be our z tilde. Our mass of our part, we're going to put a negative sign in here, just because it's a negative area. It doesn't exist on our part. So we would subtract this mass from our total mass calculation. So if we do that, we would get minus 1/3 pi times the base, which is at 25 millimeters squared, times our height, which is going to be equal to 100 millimeters, times our density, which is equal to 8 times 10 to the minus 6 kilograms per millimeter cubed. If we do that, we're going to end up with minus 0.524 kilograms. And then the last section we have to do is we're going to have z tilde for our cylinder. Our cylinder is going to have is again will be negative, and then the height of our cylinder is going to be equal to z tilde is going to be equal to 50 millimeters. Since the base of it is at z is equal to 0, and the total height is 100. The mass of our cylinder is going to be equal to minus pi r squared. In this case, our cylinder's diameter is 20. Our radius is 25 millimeters, so pi r squared times the total height, which is equal to 100 millimeters. Alright, times the density of the cylinder, which is equal to 8 times 10 to the minus 6 kilograms per millimeter cubed. Alright, if we multiply all that out, we get minus 1.571 kilograms. Alright, and then the last step we need to do is we need to calculate what is the product of z tilde and m for each of these parts. So if we do that, we would end up getting minus 19.63. This is in kilograms per meter for all of these, and then for part 2 we would get 209.45 kilograms per meter, and then for the last two parts, we would get minus 65.5 and minus 78.55. Alright, so if we sum up our last two columns, we'll get our total mass and our total value of z tilde times m. So we would get a positive 3.141 kilograms for our mass, and then our z tilde times the mass of our part would be equal to 45.77 kilograms per millimeter. So it should be kilograms per millimeter, sorry, not kilograms per meter. So then our z bar would be equal to 45.77 kilograms per millimeter divided by 3.141 kilograms. So we'd end up getting 14.6 millimeters for our z bar. Alright, so to summarize what we did in this problem is we first broke our assembly into 4 shapes. Alright, we had our hemisphere on the bottom, we had our cone on the top, and then we had 2 negative areas. We had the cone on the top, and then we had the cylindrical hole in the center. So we now have all of our four simple shapes that we broke our assembly into. Then the second step we completed was we determined our z tilde and our mass for each of our individual components. So we did that by just multiplying z tilde. We just looked up the values on this table that was given to you in your packet. So once you have those formulas, you can calculate z tilde, and then you just had to multiply the volume, which could again be found on that table, times the densities, which are given to you in the problem statement. Once you have all those values together, the last thing you need to do is just sum up all the masses of the individual parts and sum up the product of z tilde times the mass for each of the individual parts, and then you divided those two values together to determine z bar. All right. The only thing I'll mention here before we conclude the problem is make sure if you have negative values in your the main thing here is make sure you keep track of your negative signs. So if you have a negative volume, so it's like a hole or something, make sure you include the negative sign in your mass, and then make sure that you keep an eye on the negative signs for your z tildes as well. Okay? All right. That's all, and that's the last example we have for this lecture.